Hi, this is Alhed with Logos Learning, and in this video I'm going to go over the product rule and the quotient rule in a series of videos that I'm making called How to Derive Functions. So now we're in part 2. Suppose you have function h of x which is equal to f of x times g of x. The derivative of h of x is going to be the derivative of f of x times g of x plus f of x times the derivative of g of x. Now in the first term I derived the first function, in the second term I derived the second function. Okay? This is the Leibniz notation that is equivalent to this rule. So the derivative of f times g is equal to g derivative of f. So we derived the first function, and in the second term we are deriving the second function. Now h of x is equal to x cubed, that's our first function, f, suppose, and the times g, which is x squared plus 4. Let's derive. H prime of x is the derivative of the first, so 3x squared times the second function, x squared plus 4, plus the first one the way it is, x cubed, times the derivative of the second, which is just 2x. Now, you gotta make sure that you recognize this function as a product and you derive it as such, because a lot of people make the error of thinking that there's a plus here and then derive it using the sum rule. So 3x to the power of 4 plus 12x squared, so I basically multiply this through, plus, and we're going to multiply these together, 2x to the power of 4, so we can put the like terms together. We have 3, 2, so 5x to the power of 4 plus 12x squared. This function h of x is a product between the first one here, which is x cubed plus 5x, and this is the second one, which is x to the 5 minus 7. Let's derive. H prime of x is equal to the derivative of the first function, so 3x squared plus 5 times the second function the way it is, x to the power of 5 minus 7, plus the first function the way it is, x cubed plus 5x times the derivative of the second function, which is 5x to the power of 4 minus 0. So I'm not going to simplify this. You can do that on your own. Don't forget that here in this case you would have to FOIL it. First terms, outside terms, inside terms, last terms, FOIL. And here you basically just multiply this with that and this with that. Okay? So you can do it on your own. Let's move on to the quotient rule. So here our function is a quotient of f of x over g of x. Now, in order to derive a function that is a quotient, you have to apply this rule. Derivative of the first times the second function, minus here, as opposed to the plus in the other one, the first function the way it is, times the derivative of the second. So now you notice here that this is almost like the product rule, except that there is a negative sign here. But another difference is that we have to divide the whole thing by g of x squared. So remember here that this is not derived, this is the function of g of x. Let's apply this rule. Suppose you have h of x, which is equal to 2x minus 5, so this is our f, divided by x squared, which is our g, just to stick with this notation here in the rule. Now let's derive. H prime of x is equal to, we said, the derivative of f, which is times g of x, which is x squared, minus f of x, which is 2x minus 5, times the derivative of the second one, or g, so 2x. And all of that is over g of x. Now, let's simplify a little bit more. So 2x squared minus, we're going to multiply 2x by 2x, so 4x squared, and 2x by minus 5, so minus 10x. And all of that is over x now to the power of 4. You multiply the exponents. We can keep going a little bit more. So 2x squared minus 4x squared is minus 2x squared minus 10x, so plus 10x over x to the power of 4. You could keep going here. You can take out an x from each term. If we take out an x from the top, from the numerator, we're left with minus 2x plus 10, and that's over x to the power of 4. So you cancel out this x with this. This becomes a 3. So we're left with minus 2x plus 10 over x cubed. This function h of x is equal to 1, which is f, over 2x cubed plus 6, which is our g. Let's derive. So h of x is equal to, we said f prime, so that's going to be a 0 because it's a constant. So 0 times g the way it is. So 2x cubed plus 6 minus f the way it is times the derivative of g, which is going to be 6x squared, and that's it. And all of that is over 2x cubed plus 6 to the power of 2. We're just following the rule. So this whole term, since it is multiplied by 0, is gone, thankfully, and we're left here with minus 6x squared over 2x cubed plus 6 and all of that squared. I'm going to leave it like this, and later on we're going to revisit this exact problem, but we're going to solve it, or we're going to derive this function using a different rule called the chain rule, and you're going to see how we're going to arrive at the same answer. Let's do one more example. Let's derive. This is f, and this is our g. So to derive a quotient, we have the derivative of the first, so that's going to be 4x plus 4 times the second function, which is x plus 1, minus the first function the way it is, so 2x squared plus 4x times the derivative of the second, which is just going to be 1, over x plus 1 squared. 4x times x is 4x squared. Here 4x, that's going to be plus 4x, so plus 8x plus 4, minus 2x squared, and that the minus changes that sign here as well, so minus 4x divided by x plus 1 squared. 4x squared minus 2x squared, so that's going to be 2x squared. So we're going to just put together like terms. Now plus 8x minus 4x, so that's going to be plus 4x plus 4, and that's going to be over x plus 1 squared.